Hey all, this video is going to be talking about using the SolidWorks Toolbox in order to create cams. Since we've been talking about cams so much and been making them by hand, we're going to look at another way to make them here. With that, SolidWorks Toolbox you can find under the SolidWorks add-ins, and you're going to go ahead and enable the SolidWorks Toolbox right here. And what that's going to do is that's going to add a number of add-ins once we load here. And you'll see that a bunch of stuff changed over on this side of the screen. We're specifically after this cam feature right here. However, with this, we can also create a toolbar for this. If we go ahead and right click here, we can add a toolbar. And right down here, we have the toolbox toolbar, which is going to have those same functions as we found in the SolidWorks add-ins tab. So with that, I'm going to go ahead and enable the toolbar and move it over to the side where it's out of my way so that I can use the functions. With this, when I click on this, I'm going to get a pop-up that's on another screen and pull it over here. Then this is where we're going to go in order to create our cams. So with this, we are going to just focus on our base circular translating cams. However, as you can see, we do have the option to create different types of cams here. If I go to between circular and linear, you're actually seeing right in the preview up top here that yes, we have a linear cam where it's just a follower that's going to go up and down as it follows some path. That's not what we've been working with. We've been working with circular cams, so we're going to keep with that. We're going to have a translating piece. There are different aspects that we can design this for, whether we want a rotational piece, a piece at an angle, or our just base following piece, which we're going to leave it to. And then with this, the last two things we have to do is we have to determine where we want our cam to start. So we have to set a starting angle and a starting radius. Starting angle, you're almost always just going to set to 0 because you need to define 360 degrees either way. The starting radius is whatever you want your cam height to be at that 0 degree piece. So I'm going to go ahead and set that to 2, since the piece we've been working with for our follower works between 2 and 4 inches pretty darn well. So with that, we have 2 extra sections here. We've got the motion section, and we're going to instead focus first on this creation section. All of these pieces here have to do with the size and properties of our cam as a whole. Some of them are required in order to run this, some of them are not. So with that, the first thing we have is we have our size for our blank, the outside diameter, and the thickness of our blank. So this is basically what our cam is existing on, and we're going to have that be a maximum diameter that is at least the same size, if not larger, than the largest radius that we're working with. So in this case, I'm going to create a cam that goes between 2 and 4 inches. So I want to make sure that I have at least 8 inches here. Otherwise, it's not going to properly create the cam for me. And then with that, I'm going to set my thickness to 0.3 inches. That's just the size that my overall cam mechanism that I'm going to use this test on is already set at. So I've set that thickness. With that, the next thing that I have to talk about here are the near hub and far hub diameter and length. So these guys can be left blank. We're going to actually explore what it looks like with them in versus not in. And this is going to more or less define when we have our cam, if I look at it from the side, so this is the front view right here. If I look at it from the side, it's just going to be a piece that looks somewhat like this. And what these hubs are around that hole. So we've got a hole that we're rotating around right in the middle. Around that hole, it creates little pips that are going to pop out and more or less support the cam itself. So we can set those pip sizes. So I have a 1 inch diameter on both sides, near side and far side. And then I have the length, how far they come out, but set at 0.1 inches. And then below that, I have the size for the fillet and the fillet and chamfer, the fillet radius and the chamfer on these parts just set to 0.01 inches. We'll show you what that is when we get this piece made. Now, what is required to make, or you're not really going to have a cam without it, is you're going to have this through hole diameter. That is the size of this hole right here that our shaft that's spinning the cam is going to be at. And then we have the ability to change the track. So I'm going to speed through this where I'm kind of pointing out a bunch of this stuff in video, and we'll go ahead and look at the track. So the track has two options here. So we have the option to have a blind track, or we can cut all the way through. So what that's doing is, as you can see when I switched it here, this entire background disappeared. So in one case, so if this is our cam that we have everything going on, basically we have the opportunity to have a blank that is behind it with some thickness, and I'm only cutting through to here. So I have a large circle on the far side in order to support it. And if I have it as through, I'm cutting all the way through that so that none of this is left. If I cut blindly into it, I can say I'm cutting in some certain distance. And again, this is something that I'm going to go ahead and show you guys what physically happens when we do this in our video. But that is where that command is at. So that is that. And then this last thing we have here is we have the ability to change how our uncertainty is set on our surfaces. So with this, I have the opportunity to set it as basically breaking everything in when it's determining the curvature of my cam. I can have it set it up so that it is looking at every X number of degrees. What is the angle that I want to determine the height, the distance at each of them, and that will more or less set how many parts how defined my piece is, how many parts I'm breaking into it, how smooth, how perfectly I want it to follow my curves that I'm setting. Alternatively, I can set a tolerance for it, which is saying that you're good so long as you are within X of the ideal answer. Doing it by angle is a little bit faster. Doing it by tolerance can sometimes result in a slightly better surface, slightly closer to how you want the cam to move. So those are those two options there. With this, we're going to go ahead and get into, one more thing. We have the ability to change the track surface. So the track surface is more or less setting how we're cutting it. So when we're talking about the inner, I am going to cut away all of this stuff in blue, and my cam is going to follow the outside. So I'm leaving the inside, and my cam is going to follow the outside of this surface. If I go ahead and I switch this to a outer, I am now going to leave the outside and I'm going to cut away the inside, such that my follower is going to be following the inside of this surface. And then the final option is to do both, in which case I just have a very small track that my follower is going to sit into and follow around. And we'll show that right there. So that is, the blue is basically where we're sitting at this point. We'll show this again in detail, what the result is when we get a little bit further along, but those are different options there. Now with this, we're going to get into the meat of this, which is talking about our motion tab on this. And our motion tab is what creates how we want this cam to be set up. Now at the very top of your motion tab, you're going to see that you have your starting radius and your starting angle. And this is important because we're starting at 0 degrees and we have to go all the way around. And down here we have a total distance, and we can basically add features until we get to a full 360 degree circle. We have to define what's going on around the entire circle. And we need to make sure at the very end, if we have a closed system, that our starting radius is going to be the same as our final radius, because in order to have a continuous cam, you have to have the same radius at that point, whether you're coming from a clockwise direction versus a counterclockwise direction. With this, what I did is I went ahead and I clicked this add button here, and I have a bunch of options that are going to show up for what type of motion I want to set. And I'm not going to get into all these motions in this video. I actually am going to give you guys an assignment that is going to be looking at a handful of these and determining what all of the motions look like. So I'm going to show you 2 in the video, and we'll have you look at a bunch of them on your own and determine what they're actually setting there. So with this, I can go ahead and choose my first type of motion. I choose what I want it to move to. There we go. I can say that I want to go to, using this command, to a radius of 4, and I'm going to say that I want this to happen over 90 degrees. I hit OK, and it adds that first motion type. I can then add another motion type for 90 degrees. The dwell, you're going to figure out, is not actually changing anything, which is why I don't have a change in radius at that point, no ending radius, because it's the same as the previous one. I'm going to go ahead and add another command to bring it back to 2 and a dwell. And now what you're seeing here is that my final radius, so at this point my radius is 4. For the dwell, my radius stays at 4. I then switch it to 2, and my dwell, it's going to stay at 2. And that means that my ending radius and my starting radius are the same. And if we look here, I've got 4 motions at 90 degrees, which is going to come out to a full 360 degrees, which means that I have defined my entire cyclic piece, and I am ready to create my cam. So with this, what I'm going to do is I can hit the Create button down here at the bottom, and that is going to create my piece for me. If I hit Done, I get out of this menu, and you can see that I've created the cam. And with this, I'm going to go through and show a few measurements to show where those numbers ended up. First thing, if I look at my overall thickness, I set it to 0.3, and that is where my 0.3 came in. Now, if I look at the thickness of my actual cam itself, I've cut into the cam at 0.2 out of that 0.3, which is again what I had set. I can then look at these little hubcaps on either side, and you can see that they are going down 0.1 inches. I can see that my overall diameter on the overall piece is 4 inches, and on my inner piece is 1 inch, just like I set. And then if I look in here, I have a chamfer right along this edge right here. So going through, let's see if I can't draw that a little bit better. Going through, I've got a line, I've got a chamfer right here, and then I've got my fillet, my curve right here. I've set these to be very small. If you recall, I set them both to be 0.1. So I went ahead and you can look at that, and that is 0.1, even though I didn't quite get the measurement on right there. Wasn't quite acting up correctly for me there. So there we go. I think the only thing that I didn't show that I probably should have shown is that this inside circle right here, this guy, that is my 0.25. And we'll see that that's correct because it's going to, when we get to our assembly, it's going to fit perfectly with our 0.25 inch shaft. Now with this, I'm going to go ahead and go back into my cam piece, and I'm going to change a couple of these options. First things that we're going to look at is I'm going to go through my inner outer settings. So I create a new one for outer. Looks the same from the top, but look at that. It's actually cutting out a different pattern. It's cutting out the part that was left before and leaving the part that was cut away before. This is only available if you aren't cutting everything all the way through, because if you're cutting all the way through, you wouldn't have anything to rotate about. Next thing we can look at is the both selection. And when I do that and hit create, you can see that it just cuts the line so that my follower could move within that line all the way around. And I'm going to go ahead and go back to the inner, because that is, again, what we've been working with thus far. And I'm going to change it from a blind cut to cutting all the way through. because we don't really want that outside rim. We can see that that entire outside rim disappeared from our preview image. And there is our part. Last thing I am going to do is I don't really want these little hubs on either side, so I'm going to go ahead and just delete the dimensions from the 3 rows that define the hub. And by having all of those blanks, it will know not to create that for me. And now I just have, when I create this, my flat cam piece, which is what I'm looking to create for this video. So with that, I can go ahead and I can save this as a part. You'll notice that every time I went through here, I've actually created all of my different cams. So at the bottom, we're seeing all of the different parts. Every time I hit create, I created a new part that is unsaved for a cam. So unfortunately, it's not just editing the current document when we're doing that, it's creating a whole new one. So with this, I'm going to go back to my part and I'm going to go ahead and save it so that I can add it to assembly. At this point, we've talked about everything new, but we're going to see that we do need to make a couple of changes to this that we've already made before in order to make this work. But with that, I've got my assembly that I worked on before. I'm going to go ahead and insert my cam into it in a second here. So I've got my cam. I need to save my cam to add it to there. I think I said that before, didn't quite get to it. But I'm going to go ahead and name my cam, save it. You guys know how to do that. We'll skip forward a little bit, and we'll go ahead and add our cam to our overall assembly here. We go ahead and we add our mate, saying that it is going to be on our shaft right here for our testing. We're going to go ahead and flush it up. And with that, we have a working cam, other than we have to somehow add the cam mate to this outside surface. And if you recall, what I was doing is I was selecting these two and setting the cam mate. Fortunately, as we're seeing here, the cam mate isn't selectable. It's saying that we don't have a cam here that we can work with. And that's because there's all of these sudden changes in the outside. All of those lines are not continuous. We need a continuous surface in order to use the cam mate, which leaves us with 2 options. Either way, we have to modify our cam here. So we're going to open the part. And what I could do is each of these surfaces, I could go ahead and I could add a fillet on for each of them. And that would smooth everything out to the point where my cam could move over it continuously. And I'd have to select each and every one of these and make sure they're all set up, get the right radius, and run with it. Alternatively, we've also already learned about another way to do this, which is if we take all of our parts, I'm making sure here that I'm not selecting this line right here because that will cause some issues for me. But I select all of my lines that are making up this overall cam shape. And what I can do is I can use my fit to spline command, which you guys used for the first cam that you made. And I can use that in order to create a cam that is very close to this overall shape. Probably just as close as it was before. Go ahead and leaving the fit spline tolerance to what it was. We're not particularly focused on that at this point. But we now have one outside continuous surface, and we're not having any jumps around that would cause issues for the cam mate. So I can go back into my assembly. It's telling me that I need to update the assembly because I updated my part, which is exactly what I want it to tell me. And I go ahead and add those mates. And I go back to mechanical and, oh look, all of a sudden my cam mate is available. And I can add that mate. And we have our continuous movement right there. And if we forward through a little bit, I go ahead and set this up as an animation with a motor like I did before. And I can look at what my overall motion looks like for my dwell as well as my other mate here. And I recalibrate, look at my overall graph with this motion. And you can see that we have our jumps from 2 to 4, just like we set them right here. And we have our dwells where we weren't changing any heights, and those are just flat lines. So we have created the cam we set out to create. Hopefully that was helpful, and have a great day.